Hello everyone. I actually came across this question a couple of days ago, and I would like to share the solution with you. We have to prove that this series is convergent, and it converges to this value, log base 2 of the square root of e. Let's see what we can do. So I will start with that by finding a common denominator here. So 1 plus 1 over n is equal to n plus 1 over n. Then this, of course, becomes n plus 1 to the power of n plus 1 over n to the n. The denominator becomes n times the ln of n, and this becomes n plus 1 times the ln of n plus 1, and that is the expression we obtain. The numerator here becomes ln of n plus 1 to the n plus 1 minus the ln of n to the n. Then we bring the exponents next to the lns, and the expression becomes like this. The next step is to separate this fraction into this term over the denominator minus this term over the denominator as well. And this is what I'm talking about. N plus 1 cancels with n plus 1, as well as these lns. We do the similar thing for the second fraction, and we get a nicer expression. So the series we are asked to prove that it's convergent is now represented as this difference. In order to prove that this series is convergent, we need to remember the following. We need to remember that a series AN, any series AN, is convergent if the sequence of the partial sums Sn, where n belongs to n, is convergent. That's the very first theorem we usually see when we start studying series. Moreover, if it happens that the sequence of the partial sums is convergent, then the sum of this series is the limit as n goes to infinity of Sn. Thus, our goal now is to prove that the corresponding sequence of the partial sums is convergent and find its limit. Let us first find some partial sums to remember the concept. So the first partial sum is just S1, where we replace n by 2. Why 2? Because if you remember, the series in the main question is the sum n equals to 2 up to plus infinity, so we have to start with 2. What about the second partial sum? Well, it's this term replacing n by 2, plus again this term with replacing n by 3. So we get this. S3 is the same concept, and so on. Thus, the nth partial sum is the following. And look what we have here. This term cancels with this term, as well as these terms, and these, and everything. So it turns out everything is cancelled, and we are left with the very first term and the very last term. What do we call such sum? That is a telescoping sum. Therefore, Sn is just this expression. And obviously, the limit of this expression exists. As n goes to infinity, this goes to 0, and therefore we have proved that the sequence of partial sums Sn is convergent, and consequently, the corresponding series, which is a telescoping series, is convergent as well. And therefore, this is the sum of our series. Now, in order to convert this into log base 2 of the square root of e, as asked in the question, all we have to do is just apply some properties of logarithm, and that's it. This is simply 1 over 2 over the ln of 2. So the top is half times the ln of e over the ln of 2, which is the ln of the square root of e over the ln of 2. And what is this? It is simply our answer. It is just the following formula. Log base a of b is equal to the ln of b over the ln of a. And therefore, we have solved our question. Thank you for watching, and see you in the next video.